All right, let's do a little bit more. Here they ask us to find the derivative of this equation right here, which is a little tricky. However, all we will need to do is just use the quotient rule. So quotient rule is low, oops, let's imagine we have f over g. The quotient rule is low times the derivative of the high minus high times the derivative of the low over low squared. Excuse me. So let's apply that to this function right here. So we take the derivative, p prime of t will equal, we do the low squared. So I'm just going to take all of that to the 2 power, like that. That's the low squared. Now we do low d high minus high d low. So notice that the top is a constant. So when I do low d high times the derivative of the top, I'm just going to get 0, which is just going to cancel that entire term. So that's kind of nice. Don't forget your negative sign though. Minus high times the derivative of the low, so 5,740, times the derivative of the low. So derivative of the low, that 1's going to go away. And take the derivative of this, the negative 0.4 is going to come down and multiply by that 4.74. So let's do that. 4.74 times negative 0.4. We get negative 1.896 e to the negative 0.4t, and that's it. So there may be some more simplifying we can do, but I'm just going to leave my answer like that. All right, we just saw an interesting derivative problem. That kind of concludes exponential growth. Let's look at exponential decay. We saw earlier that it was p of t is equal to some starting amount times e to the kt. That's the model for exponential growth, where p is your starting amount and k is your percent growth represented as a decimal. Okay? That's growth. All we have to do to make it decay is just add a negative sign right there. So if k is positive, it's growth. If k is negative, it's actually decay. And that kind of makes sense because instead of doubling and doubling and doubling, it'll half and half and half. So a rate of decay of 8.1% would be dn dt equals negative 0.8081 n if we're doing n as our variable. So an equation for this model would just be, you know, n of t equals whatever our starting amount is times e to the negative 0.081 t. And you'll notice this is the exact same idea as our exponential growth model, except that it's just a negative in front of the percent. That's it. It's a negative up there, and everything else is the same. So suppose that there was 800 at time equals 0. How much would there be after 5 days? Well, all you have to do is plug in 800 into our starting amount and plug in a 5 for our days. And this is assuming, of course, that t is in days. So let's go ahead and solve that. Let's do 800 times e to the negative 0.081 times 5. And when we do that, we get that there is approximately 533.58 remaining. And if we round that to the nearest number, it would be 534 grams. And that's really all there is to it on these. Let's look at the next question. After how many days will 800 grams remain? So, after how many days will half of 800 grams remain? Okay, I was going to be confused there for a second. So after how many days will 400 remain? Well, to do that, we just use this equation again, and we put in 400 and 800. Because we started with 800, and the question was, how long will it take to get down to 400? So we just solved this equation for t. And in a way, we're finding the half-life here, since 400 is half of 800. So we get 1/2 is equal to e to the negative 0.081t. And we just solve that equation. Take the natural log of both sides, which will cancel the e. So we get natural log of 1/2 is equal to negative 0.081t. And then you just divide by negative 0.081. Notice that a log will be negative if it's less than 1, so this will be 2 negatives make a positive. So I do the natural log of 0.5 divided by negative 0.081, and we get that after around 8.6 days will be the half-life if you round to the nearest tenth. Because again, remember, we were assuming that t was in days. Let's do one more, and then, in fact, let's actually stop this video here, and then we'll do another example. If you have any questions, please let me know.